No, good. All right, here we go. You will need your calculators for some of these problems, not for all. This is review. This will go a little faster than what our unit circle review went, and you'll see why here in just a bit. Now, if you didn't take me with log and exponentials, I'll tell you right now, there is a system that I use. It's called the reverse Hart method. It's the fastest and most efficient way to solve logarithms and exponentials. Okay? If you know it a different way, that's fine. You can use your own way, but still try to see what I'm trying to show you because it may be faster than what you use. All right, e to the 2x minus 3 is equal to 75. It is given to me in what form? Exponential. Exponential or logarithmic. Those are the two that we're working with as far as today. Okay? They are interchangeable because they're inverses of one another. So looking at this, exponential. I can, if I want, solve for this by rewriting it in logarithmic form. Okay? Some of you might say, I can see this and already identify. I can take the natural log of both sides, and that would be fine just as well. The natural log of this side cancels with the e to create what number? 1. Good. Multiplicative cancel. So that 2x minus 3 is no longer the power, but comes downstairs. It's now the base. 2x minus 3. Natural log of 75 is what's left on the right. Now, from here, all I have to do, and I can use a calculator in this, or I can write it, is I'm going to add 3 divided by 2. So x is equal to the natural log of 75 plus 3 divided by 2. Go ahead and put that into your calculator for the sake of speed. And to 3 decimal places, please tell me what you get.
If you just type in like log and natural log of 75, it shows up on the other side as natural log.
Say again?
Really?
What did you say, though?
Like he didn't put control in it, so it didn't.
Oh, thank you. Thank you, Royce. In the calculator, let's go to the calculator real quick. Now it's going to freeze on. Natural log of 75, if you just press enter, it stays the natural log of 75. With the new calculators, for you to get the decimal answers, you need to press the control key. Then press enter. Get in that habit. Every time you want to know an answer, press control, enter. Because it's going to give you that decimal answer. So let me show you what I'm talking about real quick. Alright, so calculate. If I put the natural log, which is control e to the x, and I put 75 and I pressed enter, it's the same thing. To get the decimal, I press control enter, and it gives me that approximate decimal. Now look what I have here. 31749. Let's pretend this says 31759. And I asked you to round the answer. What would the answer be? 318. 4.318. If I asked you to truncate, and it still said 31759, but I asked you to truncate the answer, what would you write? Just the 317. You don't round that 7, you just write and you stop. Truncate means you write the first 3 and you stop. Round means you're rounding. Yes, truncate. And that's the protocol for your test. If you are not specifically told what to round to, the nearest 10th, 100th, whatever, you always round to 3 decimal places. Or you always truncate 3 decimal places. Are there any questions?
So it doesn't have directions, either one is fine.
Either one is fine. If it doesn't have directions. But if it says round to the nearest 10th, round to the nearest 10th.
For like 3.17.
I will not count off. If you put 3.18, I will not count off. You understand? Rounding or truncating are good. Just make sure I will count off if you don't do it with 3 decimal places. Now, if it's 3.700, you don't have to write the zeros to make sure that you get the full credit. You know what I mean? I'm just talking about when they're significant. All right, so let's go back. We go to the decimal number. I don't think I got it from you guys. What was it? Yep. X is equal to that. Approximately, please put the squiggle approximates. It's not the exact answer. In the squiggle, I know I did that a little bit weird. There's the approximate answer, just like it is on your calculator. Let's go with B. What do I do with B? Factor. The first 2 terms of these things, of each binomial, what are they going to be? E to the x. Yep. E to the x times e to the x is e to the 2x. Because exponents that multiply with the same base, what do I do with their powers? I add. Okay? Power ratio power you multiply. But these are exponents with the same base. And you saw this as a to the n, times a to the m. This equals a to the n plus m. So this would give me the 2x. This says my signs are going to be opposite. This says the bigger one is going to get the negative. So when I do this, one's going to be positive, one's going to be negative. I need factors of 10, and when I add them, I get negative 3. 5 and 2. 2 with the positive, 5 with the negative. So factoring is very important. If you struggle, please don't by next week. Alright, so I have two questions. I have e to the x is equal to negative 2. I also have e to the x is equal to 5. How can I get x on the left one? Apply the natural log to both sides. When I've applied the natural log to both sides, just like Megan said, it does cancel this out to 1, and it's natural log of negative 2. If you want to give me the decimal, that's fine. For the sake of time, I'm not worried about that. Well, I do worry about this negative 2, though. It does not exist. Please put this in your notes somewhere, because this is what most people miss, even when they're at the end of the year. My parent function for natural log and logarithmic, what's the domain? Greater than 0, not equal to. Okay? Natural log and log, in case you forgot, they look like this. The vertical asymptote at 0 for x. Okay? So if you have 0, or you have a negative, it doesn't work. Just out of curiosity, what's the natural log of 1? 0, yes. The natural log of 1 is 0. Natural log of 1 is 0. What's the natural log of e? 1. Good to remember. Again, what is the natural log of 0? Does not exist. Define. Alright. Now, what's the answer for this x? Or natural log of 5. Yep, you're right with the 1.6, whatever you said. Okay? Let's go now to C. C. I'm going to first do what? Okay, so you can't factor because of this negative x, right? It's a little weird. What I will do, and what I suggest to you, is always when you see negative powers, change them to positive powers. So e to the negative x is going to change to 1 over e to the positive x. So looking at this, e to the x, this negative power is only applied to the e, not to the 12. You understand? If it had parentheses around 12e, then it would be applied to both. So basic stuff from Algebra 2 shows the 12 will stay up top, and this becomes my equation. Algebraic manipulation. Okay? Now, what would you suggest that I do next? Multiply everything by e to the x. I need that out of the denominator. Get it out. So when I multiply everything out by the e to the x, it's to both sides. So that I get e to the what over here on the left? 2x. Good. Thank you for not saying x squared. Okay? Plus 12 minus, so I'm going to put the 12 here, minus 7 e to the x. So now I think you know why I put the 12 there. Because we're going to factor. Is this legal, though, that I can just multiply stuff by e to the x? Yeah. Okay. Let me do it to the other side. It's a form of multiplying by 1. Alright, so let's factor this puppy. What do you get? Perfect. E to the x minus 4, e to the x minus 3. They add to the negative 7, and they multiply to the positive 12. So this first one is the natural... Oh, sorry. Go ahead. Okay. So this first one, e to the x minus 4 is equal to 0, says e to the x is equal to 4. So then x is what? Say again? Perfect, natural log of 4. For the sake of time, I'm not going to convert that to the decimal right now. I'm going to keep going. What's the other answer? Natural log of 3. Whoops, not e, 3. Alright, so now let's go to D. I think we're going to finish just in time. We're going to have a good time. Alright, D. Kenzie, what would I do? Megan, help her out. What would I do? So yeah, you're multiplying by e to the x plus 3 and dividing by 5. So basically, if you don't see it, we've done it today with other problems. Flip-flop those two. 18/5 is equal to e to the x plus 3. You see what I'm doing now? Travis, what do I do next?
You would take the natural log of 3/5. Is that where you lost?
Not yet. No. I think you're ahead. I'm going to what? Move the 3. Subtract the 3. So 18/5 minus 3 is equal to, we're trying to isolate that e to the x. So that, then we can take the
Oh, okay,
natural
so I
log.
did different.
Yeah, I did it a little bit different.
I did,
Okay.
I distributed the 5.
Oh, okay. That would still work as well. That should work as well.
So I erased
That should work as well. Okay. From here, I just take the natural log. So if I wanted to, it'd say 18/5 minus 3. This is x. The equivalent, those of you who change it up, just to double check it, I think you're right, but it should come out to a negative 0.511.
Yep.
Okay. Can I have a negative though? Yes, I can as an answer, just not as the argument in the natural log. Just not. This part cannot equal a negative. All right, we move on. Natural log of 3x minus 2. Let's go with Griffin. What do I do?
I would change it to
Good. All right, so looking at this, let's change it to exponential.
do a hard thing.
So I can do the hard thing, or I can apply e as a base to both sides. Okay, the hard thing is coming, okay? But this is another thing that you can do. Because if I apply now, this is the base ground level. These cancel to what number? 1. The power still comes down as 3x minus 2, e to the 5th. See it? All I did was apply the base of both sides with e. It's the same way as apply the natural log to the ones that we were doing that had the base e. It's just a different way of canceling. Okay, they're not on the same level. One's in the power, the e's in the base, and they cancel, the power comes down. Then I would add 2, divide by 3. So x is equal to e to the 5th plus 2 downstairs, divided by 3 in the basement, or in the denominator, and that is my equivalent answer. Whatever you got, I think you should get 50.138. Okay. Let's move on. Royce, F. Here's the reverse Hart method.
Yeah, I just learned to go like 2 over into the broad side. Like I did 10 squared equals 4x plus 3.
Nice. What is the base of what you see right now?
It's like in 5.
It's in 5 that it's 10. It is 10. A common base, if it's not written, if 1 is not written there, it's 10. The reverse hard method, we always start at home base. Then we run the bases. Home base, first, second, third, and home run. So start at your home base, and you're going to do a reverse Hart method. I'm doing the logarithmic to exponential. So I'd say 70% of the time when you're doing logarithms and exponentials, if you're given it in a logarithm form, change it to an exponential, then solve. If you're given an exponential form, change it to a logarithmic, then solve. You with me? Alright, so we're changing this to exponential. 10 to the power of 2 equals the argument. So 100 minus 3 divided by 4 is x. 97/4 or the equivalent of 24.250. And you don't have to put the 0, but if you did, still be correct if you did it. Alright, so law of logs. LOL for G and H. These are the same. That's addition. What does that mean? I multiply the arguments. So x plus 3 times x minus 2. This is still the same. What am I going to end up doing to move this over? Say again? Not divide. Subtract. So I need to subtract this. What I did was just change it log base 5 of x plus 3 plus log base 5 of x minus 2 minus log base 5 of 14. It's not a quadratic. There's the multiplication. Division is going to be divided by 14 because this is subtraction. Subtraction is division. We are combining these to one huge log base 5. Law of logs. When they're separated out like this and they're adding, there's multiplication. When there's subtraction, there's division. Are we good? Not yet. We're going to get to it. This one's more involved. This one's a longer problem. Definitely expect one this difficult next week. Let's go with first process. What would you do? You could FOIL the top, yes. FOILing the top would give me x squared plus x minus 6 over 14. Right? Reverse Hart method says that I could start at the base to the power of 0 is equal to this whole thing. Anything to the power of 0 is what? 1. Except what two things? 0, that's indeterminate. 0 to the power of 0, we don't know. And infinity. 0 and infinity, those are two concepts. 0 is a number, but also a concept. More so a concept. We'll learn that this year. So 5 to the power of 0 is just going to be written as 1. You see what we're doing now? Multiply both sides by 14, so that I have x squared plus x minus 6 is equal to 14. And then we're going to subtract the 14 over. So that we get x squared plus x minus 20 is equal to 0. And from here, this isn't bad. This is easy. What are the two factors? Good. X plus 5, x minus 4. So my answers are x equals negative 5 and 4. That's a lot of work, right? Guys, 20% of the time, maybe 20 to 30, I will allow you to use calculators on the test. Okay? Most of your tests will be without a calculator. So you got to get good at number crunching, number sense. You got to get good at algebraic manipulation. Okay? So when I do train you with the calculator, you're going to be upset with me because you're like, really, we could have done this, but there's only certain pieces of the AP exam that you can use a calculator. More of it is without. All right, H. What do you suggest? Keeley. Yes. So 2x plus 1 divided by x minus 2. Keeley, why can I do this? The base of the logs are the same. Law of logarithms. From here, I'll probably do what, Emily? Okay, so how do you bring the 1 over? No, not like that. What do I want to do? Anyone, what do I do? Reverse Hart method. It is in logarithmic form. Let's change it over to exponential. How do I know that? Because this really isn't in the standard logarithmic form, is it? Okay, that's when I manipulate it. Once it's in logarithmic form, base argument number, then I can do the exponential. 4 to the power of 1 is equal to that. So 4 is equal to 2x plus 1 over x minus 2. Travis, what do I do next?
You just take the x minus 2 and multiply it.
X minus 2 multiplied by 4, and I get 4x minus 8 is equal to? Justin, what do I do next? Come on, Justin.
I'm letting out.
It's all good. Hannah, what do I do next?
Staring at
You go.
Stay with me, guys.
Oh, I added the 8 and then subtracted the 2.
So 2x is equal to 9. X is equal to 4.5. The last one, bonus points. Here we go.